Again, anytime we're working with a geometry problem, we normally want to draw a diagram. In this case, we know we're looking at a square, and that square is square ABCD. I'm going to label the vertices A, B, C, and D. And we're told that point E is somewhere between A and B. We don't know where, so we're just going to put it somewhere. And point F is between B and C, so let's put that up here, just kind of generically. And we want to find the sum of the measures of angle AEF and EFC. So if we draw in the line segment from E to F, that's angle AEF and angle EFC. And I'm going to label the measures of these angles X and Y just to make things easier. Now there's a few different ways to go about finding the sum X plus Y. The first way involves pentagon ADCEF. There's a formula for figuring out the sum of the angles in a polygon. If you have an n-gon, meaning a polygon with n sides, the sum of the angles is given by 180 times n minus 2. In this case, when n equals 5, that's going to be 180 times 5 minus 2, which is 180 times 3, which is 540 degrees. So this formula tells us that the sum of the angles of that pentagon will be 540 degrees. If you don't know the formula, you can actually derive it pretty easily. Let's just look at a pentagon. If we have a pentagon and we want to know the sum of the measures of the angles, we can actually put in some diagonals and turn it into a bunch of triangles. And in this case, it becomes 3 triangles. So we have 3 triangles. But notice that the sum of the measures of the angles of the pentagon is equal to the sum of the measures of the angles of all the triangles. If you take all the angles of the triangles, one at a time, and you add them up, you end up with all the angles of the pentagon, and none other. And we know that each triangle, the sum of the measures is 180 degrees, and so if we have 3 triangles, that gives us 3 times 180 degrees, which gives us 540 degrees, as we saw above. Now, if you look at the other 3 angles in the pentagon, angle A, angle D, and angle C, those are all right angles because the original shape was a square. So if we add all those angles together, we have the 2 angles we were looking for, X plus Y, but then we also have angle A, which is 90 degrees, plus angle D, which is 90 degrees, plus angle C, which is 90 degrees, and we know that that total is going to end up being 540. Now if we add 90 plus 90 plus 90, that's 270, so the left-hand side becomes X plus Y plus 270 equals 540. And if we subtract 270 from both sides, that gives us X plus Y equals 540 minus 270 is 270. And that's going to be the sum of the angles that we wanted, and that's 270 degrees, which is answer choice C. But there's another way to solve this problem without using the pentagon at all. Let's focus on the triangle BEF. Let's say that the measure of angle BEF is A, and the measure of angle EFB is B. Because AEB is part of the square, we know that that's a straight angle, and so we know that the sum of those measures, X plus A, has to be 180 degrees. Similarly, we can see that Y plus B also has to be 180 degrees, because that's a straight angle that comes from the side of that square. But we also notice that A plus B has to be 90 degrees, because when you have a right triangle, the sum of the angles will be 180 degrees, and when you take away the right angle, the sum of the remaining angles has to be 90 degrees. If we add these first two equations together, that gives us x plus y plus a plus b equals 180 plus 180 is 360. But we know that a plus b is actually 90. So this gives us x plus y plus 90 equals 360. If we subtract 90 from both sides, that tells us that x plus y is 270 degrees, just like we saw before, also answer choice C.